Welcome, David Krakow from Verada. It's a great opportunity to speak with you. I've been learning all about Verada's technologies. Verada is a platform, or it creates a platform that enables data scientists, data architects to accelerate, optimize workloads with adaptive indexing, which is something I think we can go into a little bit later. I was looking a little bit into your background. You have a pretty long and strong background in storage, software development, and I notice it's mixed up with a lot of leadership as well. So it looks like you've been in all the different areas of the tech business. Tell me a little bit about your background and how you came to identify this issue that led to founding Verada and what Verada is there to solve.
Sure, I'm very happy to be here speaking with you. As you said, my background is software and storage, and the latest company I've been with together with my co-founders was called XtremeAIOS in the space of all-flash storage. It's basically a company that revolutionized the all-flash storage market and became the market leader in just 3 or 4 years. And one of the things that made it possible for them is that they used hardware and software in a different way. They identify what changed in the data center, what changed in hardware, what changed in what is possible to do, and wrote the software to exploit that, wrote the software to leverage that. And as a storage company, a lot of business increasingly we're in the area of data, of big data, of specifically enabling better workflows in Oracle and such. Mm-hmm. And what we've seen, my co-founders and I, as we launched Verada, is that kind of a revolution that the hardware enables the software to do differently has not been existent in the big data world, who took a very specific course of how to handle big data that was mostly stemming from the roots of the different approaches to technology, whether it's from Yahoo building Hadoop or from the data warehouse and vertical world. So there's just vacuum on how you approach the problem technical-wise. And then on the other side, just so much huge pain in that space. And and probably the first 6 months or so of Verada, we just spent talking to customers and learning even more and more about that pain. And just do a few different parts of that. And even though that's, they say that 80% of big data projects are doomed to fail, this is like a statistic that people like to throw around. And probably some part of that is just because companies, when they start a big data project, don't really know where they want to go. But a lot of that comes to the actual problems of how you deal with that. Some of it of how do you even make sense of so much data, whether it's from the angle of collecting it, whether from discovering it, from even knowing that what you have.
Yeah.
And some of it of how being able to use that, to leverage that to enable analysts or tools for the day-to-day. Where if you analyst, you've got this, doing that, you've got this idea, you've got this insight, you've got this something you need to do. How fast can you get to researching that? How fast can you get to querying, to looking at the data, to finding the right data, to getting the right answer, to validating that, to moving? And this is, and well, we've seen this happening both in use cases for internal teams. So they're enterprises, they have this analyst teams, they have this BI team. But we also seen that even more with companies who actually build data products. Yeah. Companies who build external facing or customer facing, sometimes they're very large companies in general still, but products who are actually using data not to have this long-term data-driven decision on the enterprise level, but to actually do business from data.
Yeah.
To enable, say, security analysts understand incidents in their network, to enable marketing people to better understand the journeys of users across their sites, and so forth. And this kind of actually data-driven business and technology, this really exposed all the deficiencies of the technology underneath.
Yeah.
Because when you have this state of many hundreds of thousands of people using this system at the same time, everybody expects an interactive answer. Everybody expects to be able to work with the data, see graphs, see plots, and expect that to happen consistently. And there is no way for the data engineering side, the people who build that, there is no way for them to really be able to predict how people are going to use it. It's just too wide, too large, too diverse. So once you have those kinds of data products, couple that with the whole from big data set, from its volume, and its velocity, this is an extremely painful problem.
Yeah.
So when we started Verada, we knew we need to combine this two. We need to be able to tackle this basic pain across being able to getting faster insights from data without being able to predict specifically or model for a specific question.
Right.
And we knew, based on our old Flash background, that we can build software differently to leverage things that happen, because we didn't see anyone in the tech side of the big data infrastructure doing that from first principles.
Yeah. Yeah, and it's a good way to start, because you're just really describing the end state that we're at now. You know, that we've been so successful with, you know, generally with IT and with data, that people, we take it for granted. It's like when I open up the tap in the sink, I expect water to come out, and I don't think about what it takes to actually get that water there from the source, right? And given your background in storage, which I have as well, so I relate very much on the storage side of things, there's been a real history to get to this point, right? That, you know, first the data started to become easier to collect, so it grew. You know, we went from gigabytes to terabytes to petabytes to now exabytes. And then the data sources then start to become more diverse, right? Their cameras, their servers, their people, whatever, you know, all kinds of things that data comes from. And so then it starts to become more complex. And so now I guess then the infrastructure is now becoming complex, right? Now we have Amazon and Azure, and we have object storage and whatever, NAS. So I guess now we're seeing like a sheer complexity of data, just the data itself, right? You've mentioned, we were talking earlier about the thousands of dimensions that someone has to deal with. How do you approach that? Or how were people doing things before? And how does Verada actually change how you deal with that kind of complexity?
Sure. So when I'm saying dimensions, maybe just to pause on what we exactly mean by that, but this word. So yeah, big data exploded and there's so much data, but when you take just the nuance inside of it, what's happening that makes it even harder, there are two trends that happen. One is that the data itself goes to things like data lakes or object storage, goes to not to a system like a data warehouse, which is built for analytics. It goes to storage. And one reason is there's so much data coming from so many different sources and different life cycles, different bases. So it's impossible to deal with how you consume it at the time you capture it. So it's easier just to throw it somewhere. On the other hand, you've got a lot of different kinds of data that is being leveraged daily, whether it's social data or sentiment or behavioral data, IoT data. We all get tracked all the time by the big brother, and every piece of data is collected. And companies know how to leverage and use disparate sources of data to create more business value. And so it's not just about the size, it's about the complexity. Dimensions are just columns or tables, but you've got so many different properties that you collect. Like a single click on a web page can create 50 or 100 different properties to collect on that. And just that click, you want to combine that from your Salesforce data or from your support data or from other third-party sources. So, and you know, I was a computer scientist by training. So if you take like from the computer science perspective, When you double the data, it's a linear problem. How do you double? What do you do with that?
Yeah.
But if you double its width, it's an exponential problem.
Mm-hmm.
It's a much harder problem.
Yeah.
Because now you've got every possible combination, and it's by power.
Yeah.
So this makes it much harder.
Yeah.
And the second trend here, actually this is the trend of data, but on the other side, you said some things are easy and like magic, but that's part of what cloud has been doing, because in the older days, when you build, say, you've got your NetEase or Teradata or Oracle, you've got your organizational data warehouse, and it's a large rack, and it is provisioned for the year, and the budget is very controlled by the IT and the size of it, and to expand it, go and wait next year. And so the business units have to work within that boundary. And they are entirely dependent on IT to be able to allocate a piece of that and fight among themselves on what to get. But the cloud completely changed that game. Part of the things that is essentially the cloud happened in the cloud, that you can have essentially infinite resources, at least for a particular point in time. You can have infinite storage in a cloud data lake, or infinite compute to go and analyze that. And the power is no longer sits with the IT who provisioned your rack. It sits with users who can just use as much as they can, which moves the problem not only in how do you deal with all that data, but how do you also do that in a financially efficient way.
Yeah.
Because the cloud gave you a magic trick, which is you can have infinite amount of resources. You can just spend money and throw computer problem, instance the problem, and don't think about a lot of the hard problems that comes from boundaries, and it will work.
Yeah.
But then it will be very expensive, and more than expensive, you get to the CFO side of the house, unpredictably expensive.
Yeah.
Because they don't find expensive, they mind expensive, they don't know. So now we're in a world, and this will come to what Verada does, when we have to deal with that complexity of data, and to deal that not in a brute force way, because there is a solution in the cloud, which is just run as many resources as you can. If you're Facebook, if you're Uber, if you're Google, that probably works for you.
Mm-hmm.
But now, how do you go efficiently about it?
Yeah, that's probably been one of the advantages of the hyperscalers. I think, like you're saying, I think that what has happened up till now is the way of dealing with this sort of problem, this complexity, is to throw money at it, basically, just buy more compute power, buy bigger, more, NVIDIA came and helped a bit. And then that also, with the parallel processing, but then that also becomes another brute force money problem where you just throw more GPUs at it. And, hyperscalers can do that, but an ordinary business can't. They become dependent on that, or they become limited in what they can do with their data, right? So I guess it comes down to that old saying, work smarter, not harder. And right now, the solution is to work harder. So if you have that resource, you can solve the problem. If you don't, you cannot. So that's a big problem. So Verada has then found a way, or at least put to use a way, because probably the concept existed before, but it needed to be applied to something called adaptive indexing, where, as I understand it, you even choose what kind of index to use depending on how the data is structured. Is that right?
Yeah, sure. So just to give you the where we are. So Verada is a middle tier that sits between data and data consumers. Mostly on the cloud, and mostly on data lakes, because this is where the most of the complex and hard and large and diverse big data comes to, at least on cloud environments.
Yeah.
And as that middle tier, our job is give you fast performance, give you that efficiently, and give that for workloads who are hard to model in advance. Because if you could, then you might just build data pipeline just for that.
Yeah. This is like the known unknowns and unknown unknowns problem, right? If you know already in advance what you don't know, you can structure it. If not, then you have to throw money and resource at it.
Yeah, sure. So I prefer the word predefined, not predefined, because sometimes you know what you get when you get, but you can't. It's the problem is too complex to define that in an efficient way. Yeah. So this is the type of workloads we tackle, and as I said, the only alternative here is either go and model everything, which is not possible when you get those kind of workloads, or brute force your way.
Yeah.
So the technology that we do combines two very strong and different forces into one that gives that ability.
Yeah.
They are adaptive indexing, which I'll talk about as you asked, and workload analysis. So I'll start with adaptive indexing. Historically, there are indexes being used in data for quite a bit of time. Mm-hmm. But once we moved in the world of big data, you don't see the traditional types of indexes appear. There are many technology reasons to that. A lot of them related to the fact that data for analytics is stored in a columnar way. So it's related to how you store that data to be efficient to process it. And the fact that the way people can index big data today is just by sorting it on something and duplicating everything, which is, again, not really possible when you have so much data. You have a petabyte of data, you're not going to duplicate that a few times for just different types of queries. So it's a very hard problem to solve, because you have to deal with uncertainty of what the data is. You have to deal with uncertainty of how it grows. And you have to deal with the fact that there's so much of it that where you get a new piece of data, you can't really update anything behind. You can't do any garbage cleaning, any vacuuming. You have to keep the pace.
Yeah.
So our adaptive indexing technology doesn't exactly that. So let's just consider for simplicity you got a piece of operational data. It doesn't really matter how many rows it have or how many columns it have. Or as a goal, it shouldn't matter. Mm-hmm. So what we do is we have this layer. It's based on SSDs. It's a cache for those indexes, which leverages how SSDs work to deliver that. We break the data into very small parts. We call them a nanoblock. But essentially, it might be a few kilobytes mm-hmm. Of a column, of piece of a column. And this might be a very small piece, might be like, say, 60,000 rows of a column. And then for that very small piece of data, and think about if you have this 100 terabyte of operational data, that's millions of those pieces. So for one small piece of the data like that, we build an index just for it. Now that index, the way it's built and how it does, really depends on the contents of the data in just that piece.
Yeah.
If you have, you have this column, it's a temperature sensor, and it's between 70 and 72, then you've got an index for that for a numeric range of 2 degrees. Mm-hmm. You've got the user ID, which is high cardinality, a GUID. You've got an index for that. You've got text data. You got an index for that. And as your data changes, because it does, both in the data types and its contents and distribution, and what people ask of it, which just goes to more workload analysis. Mm-hmm. But as data changes, just a bunch of nanoblocks. Mm-hmm. So you get this, we think about it as a mesh, or graph of millions of small indexes. Each one of them is optimal for a small part of the data. It's entirely adaptive because each one of them is unique.
Yeah.
It's entirely dynamic because each one is independent of the others. So if data changes, new data comes in, data gets deleted, there's very, very small impact. So just building a new nanoblock.
Yeah.
And now every query becomes a walk or run across those small indexes.
Yeah.
Which is also a bit kind of a brute force, but a brute force at a very different level. we can, instead of having run across 100 terabyte of raw data,
Yeah.
we can have run on a million indexes, which are small SSD pages, and do that at 100th of the time for the same query, and do that without knowing in advance where the query going to take us. What columns do I care about? What I do with it? Because it's fully covers, and again, it's adaptive to how the data looks like and dynamic to how it changes. So this is a very big part of it.
Yeah, so it's basically breaking the problem down into smaller problems and dealing with that. I guess there's a few advantages there, of course, that each of the smaller bits is more manageable. Plus, you can do a lot in parallel, and you can do them independently of each other, right? So rather than swallow the entire, what do they say, eat the whole elephant, you just start with a bite, right? That makes a lot of sense. And basically turning big data into lots of small datas, and going from that point on. So that's a good overview on the technical side. Switching over now to the mind of the business owner, the CEO, the product owner, the people who would be financially responsible for the projects being built on data. Like I said, now data is taken for granted, but everybody's trying to turn data into value, and yet finding that when they open up that faucet, the water's not coming out as fast as they expected. How should a business leader like a CEO look at this problem? What should they look at to determine whether this is an approach that they should take?
Sure. So if you take the zoom out to the business level, the actual tech and how you solve the problem is less important than the fact that you deliver a solution that gives more value. I think that from an organizational perspective, there are two types of value here. One is just being able to do more with the data. It comes to performance, and performance a lot of time is translated to how much data you can access, is translated to how many users, how sophisticated features you can build if you're building a data product. So that comes to a lot of business value in terms of what you can do with the data. Yeah. And the second comes to how much effort you're going to put. How fast can you be? And it's not only about cost, because it's not about the cost of having a very familiar and an expert team. It's sometimes about the cost of being on time, of not being on time, and being able to deliver in a timely manner and respond fast to changes in what people need from data, how people use the data. And as I said, because we go to areas where it's relatively hard to predict, whether due to the nature of the problem, due to the nature of the data, being fast on the way to be fast, being fast on the way to being able to access data, is essentially a business need by itself.
Basically, time to market is itself a business value. And especially if your product is built from data, then the faster you get there, the faster you're to market, the more data that you can access, the higher quality your product becomes, right? So it becomes a quality versus time to market type of trade-off.
Yeah, it's not just, obviously cost has because we're technically good first, so cost has as a part of it, but cost a lot of time can be expressed in matter of unit economics. If you build a data product, you sell it to so-and-so, or whether internal customers or external customers, so you have some internal unit economics you need to adhere to, and that gives you some boundary of what you can do. Yeah. So being efficient obviously expands what you can do, but then it's about what kind of questions can you ask. If a query returns in a second and not in 60 seconds, it's just a different type of analyst flow you can support with that, and how fast you can get there. So from a business perspective, it's fast and different meanings of that word.
Yeah, no, that makes sense. And then, of course, there are obvious cases like, in regards to data, we've heard about things like autonomous vehicles or algorithmic trading. What are some common use cases that you're seeing that you're working with?
Sure. So the types of use cases that we traditionally deal with today comes from either in areas of things like marketing analytics or click-through analytics, like for a digital footprint. We have different use cases in areas of cybersecurity, event analysis, and log collection, and incident analysis. We have some, which is very similar with different space and root cause analysis.
Yeah.
And also, again, in that entirely different space, although when you take a look at how the data workload looks like, you see a lot of similarities in the areas of genomics and medical research. And some of the things you mentioned are probably might be a fit as well. One of the things those kinds of workloads is that they usually represent companies who are well mature on their journey to data. But what's part of what's happening today, that's basically every company who does not really accelerate that, who's not data driven at its core, are gonna get left behind. So you have a new industry like cybersecurity.
Yeah.
It's obviously they can deal well with data, but then you get traditional industries like car manufacturing, and those who are there and now can be leaps and miles before those who are just planning the data journey. So there's a lot of different use cases that fit here, and I think that from the enterprise perspective, it's crucial to be able to know and understand the data you can generate business.
Yeah.
And know and understand how to build an architecture on the technology side to be able to do that. Yeah. To not pay the price later of building things that are going to limit you in a year or two. And then,
Yeah, I guess it's also something to think about. The decisions you take at the beginning of a path, you won't feel the consequences till much further down the road, right? And then, decisions you make when you first start building your infrastructure for collecting data, and I think this is how a lot of companies end up having difficulties later, is that you build the infrastructure for the data you have today, and then it starts to scale. And the infrastructure you built wasn't appropriate for that scale, right? So then you end up later on with these problems that you didn't see coming until you hit that scale, right? So, one of the things that I've seen a lot of companies do, especially around data, is they'll tell you, look, we can come with a solution, we can offer you numbers and benchmarks and everything, but you don't really know what you have until you try it with your data. It's unique also. How does Verada approach that as well? How do you engage a customer to see what their data situation is like?
Sure, but one of the comment, like one thing that I think that a lot of companies should just think about how the data architecture looks like, which is very important. That, at least from my perspective, to keep in mind is think about decoupling between how to get the data in and how to consume it. Yeah. One of the hardest things to deal with it later is entangling those two. Is writing the data in the way you're going to query that, and querying the data in the way that was written in. And there are different technologies here, like data lakes and others, who can do this kind of decoupling. But I think, at least from how the architecture should look today, this is a very big part of not running into boundaries later. Yeah. And kind of decoupling enables, for the same data, different uses. Whether it's interactive analytics or data products with a product of ours, or maybe data science, or machine learning, or understanding data quality, and all of those different uses for the same data or around the same data need that decoupling. Yeah. And for understanding, so part of what you asked me a question, and understanding what people can do with the data is a big problem. And one of the things that we do as a product, but we also offer that as a way for customers to just understand what's happening, understand if we can be a fit or not, or understand various properties of their workloads, is workload analysis. The same way that it's so hard to predict and build a model for something where you don't know, your workload is not predefined enough. Yeah. It's hard for data architects and data leaders to understand where their bottlenecks are.
Mm-hmm.
There are the obvious stuff, you get a ticket about a query that keeps failing, then yeah, that's a fire to put out. But that's just the tip of the iceberg.
Yeah.
And when you got thousands of queries a day running across thousands of dimensions, it's really hard to know what's actually being used, what's actually important, where is our user experience deteriorates, where are the cost areas because something was not built well, efficient enough. So this kind of workload analysis is covering the blind spot a lot of data teams start to have once the complexity grows. So if we talk about rather the product, so we talked about indexing. The other side of that is workload analysis, because we can index everything, but if you have a few petabytes of storage and you only use operationally a fraction of that, indexing everything doesn't make that much sense.
Yeah.
But then you can predict what. So what we do is we have this workload analysis, which looks at the queries, looks at how people use, and has this machine learning behind to determine what's the operational data set. Mm-hmm. Now, this counts for the product inside, but externally, all of those understandings of how the workload looks like, what repetitive in it, what are the bottlenecks, what changes, we show through very extensive deep visibility engine. So you can go and understand what your workloads do. And reason about what's happening, not on the specific query, but a whole business workload and understanding how much it costs, or does it deliver the right response time that we want, is it failing or not? And this visibility drives internally how we decide what to optimize, but gives a lot of value by itself. Yeah. And we figured out that, and we started, by the way, here releasing some of those capabilities in open source, and we'll keep doing that because we figured out this is something that lots of companies need as a way to understand what's happening.
Yeah.
We use that usually to also show the value and the fit of a product like ours, saying, hey, this workload can really benefit from that. But I think that, but this, as we went to that open source route, it's an add-on. It's nice that we get some customers know where to use us, some customers will understand not to use us, which is also good in both ways, because everybody wants to have a solution that actually solves their problems, and not do those who doesn't. But then you as a customer, or you have a big data analytics deployment, you can run this kind of workload analysis and understand more about it. Understand if you use Verada, you can also understand a lot about it. So that's one reason why we started this all open sourcing journey of that part.
Yeah, no, that's a big challenge, open source, as a business model, but also, I mean, in a way, the advantage you have effectively an unlimited development team in principle, theoretically, but on the other hand, a little bit less control over what comes out of it, right? I've heard of a lot of companies weighing that, like what's the best way to go with open source. What I like a lot, though, about the approach that you're taking is, of course, the one thing is to identify what's actually important, what is actually the business data, the data that actually gets used. But I think it also, this approach of being able to, I guess the word is ad hoc, to think a little bit, be flexible about the types of questions you ask, allows you to sort of learn and adapt as well. You make a query, you learn something, you can change the query. Whereas in the traditional method, that's a lot more difficult because you have to determine everything in advance, right? So, have you seen that benefit?
Yeah, sure. And by the way, there's a hidden assumption you can know what's the next query going to be.
Yeah, exactly. You don't know what you don't know.
Yeah, we do see. So one of our design principles on that part of the workload analysis engine that drives the indexing is that it's visible, it's explainable, and it's controllable. Because one thing we don't know from analyzing queries is how important a workload is in the business. And some are more, some are less. And this is the knowledge that sits only in the domain of the customer. Mm-hmm. And so we use that visibility engine also as a control to tell us what's important.
Yeah.
to prioritize the cache, to prioritize the indexing. And this adds called business sense to, or the business context to the data engineering work.
Yeah.
In a way that's relatively easy to reason about. Yeah, you can go and optimize. I want this column index, and that way you can go and like control the bits of that. And sometimes you might want to do that, but most of the time now you can reason about it not on a specific query and the next one that comes, but on a workload level that there's a collection of different queries, and you can hint sometimes that this is more important than others.
Yeah.
And I think this is a powerful way to think about it, and it's new. It's new both in terms of capabilities and in terms of philosophy on how to go about this problem, how to deal with that unpredictability.
Yeah. That's great. I'm curious a little bit also on the leadership side of things. Verada is, of course, a fast-growing company in a very, well, let's say it's a hot space. It's very competitive. The tech business all around, especially around data, there's certain technological areas that are growing really fast. What has it been like for you to lead a technical team through this? And do you find it challenging to keep your technical team connected to the business value of what you're providing? And how do you motivate your engineers to, really know why they're waking up every day and what's the problem they're solving, why they do what they do?
Well, that's probably one reason I went to startups. One of the nice things about a startup, at least if you build the culture the right way, is that everything's transparent. In a small team, everybody celebrates the wins. Everybody feels the losses. Whether it tells about the bugs of that the engineering had to deal with, or the version that released, or the other way around. Yeah. And by the way, a very separate topic, but one of the things that COVID forced us to work remote actually increased that kind of transparency.
Yeah.
As a team who has a base in the US, mostly front-facing, customer-facing, sales, and engineering in Israel. So we remote by how we build that, but it still was an on-site team here and there. And moving to that forced remote increased that transparency and increased that culture of, everybody knows what's happening, but from the engineering to the sales side. So
that's amazing. People got very used to being remote. Even people not in the tech business, like even, your aunts and uncles now understand how to work remote.
Yeah, I can Zoom with my grandma.
Yeah, it's amazing. So yeah, no, indeed, it's very hard to maintain like corporate politics in a small startup. And I had worked in the past in a small company, and I remember the VP of sales saying that if you work in this company, your first job is sales, your second job is whatever you were hired to do. So that's always a really good one. So where do you see Verada going in the next year?
I think we just, so the product we talked about, we just launched it right back now this month. So, and has some early adopters, and I think this is the year where we can move from this early adopter phase where we know it works, but we get that to the maturity that we take to the market.
Yeah.
And now the point where we can onboard a lot of interesting good use cases. We're not the strictly very tech-friendly early adopter type, because product get mature enough to be able to integrate, to able to deliver by itself. So definitely our focus for this year is that. While on what we do side, or the product side, it's not just improving the indexing. The workload analysis gets smarter the more and more workloads we work on. And one nice thing to building that way is that it accelerates by itself, and accelerates not only just for the growth of the company, but for every customer that uses the product. Yeah. Because the more the engine gets smarter, the more everybody benefits. So I hope and I believe that we will see that kind of a positive feedback cycle. The more workloads the workload analysis engine learns. And by the way, just to clear some worries that might come here, the way the product works, it works within the custom environment.
Mm-hmm.
So no data ever leaves the premises of the customer. Right. We're not a SaaS solution. Yeah. And we work with financial and PAI and different industries with regulatory concerns. And it's fine because we don't actually leave the premise of the customer, except and only when there is a consent to telemetry.
Yeah.
And so teaching the engine how to work better, but doesn't really care about specific queries or data or anything like that. Yeah. And again, this is also with consent from customers.
Yeah, that's a big point, because regulation, privacy, security, these are big points when dealing with data. And I would even, that's an important point you make, that data stays where it stays. In some cases, like, when it has to be encrypted or things like that. But I would even say the other way around, this would allow you to know yourself what the data is and be more in compliance, I think, as a result.
Yeah, actually, it is, from a customer perspective, there's always a benefit to be able to run something inside and not use a SaaS solution or external solution. Yeah. Once you have that there's always types of data it's harder to move external, whether because regulation or because some contractual obligations to third parties. And so whatever SaaS solution you have, it becomes a data silo.
Yeah.
Because not all of the data can move there. Data that can move there might have required anonymization or different life cycle. So just being able to control everything within.
Yeah.
Doesn't matter which technology you use, but it has a value by itself. It makes the compliance and the security story easier. When there are less owners for the data around to deal with.
Yeah, no, that's a big challenge. I'm also working with companies that do services in the cloud. And first of all, they have to assure customers that they don't in any way introduce any risk. But secondly, just going to the cloud is already a big challenge because of these issues. So that's very important that you say that. And speaking of that topic of cloud, so, obviously we're called Cloud Native X, and Cloud Native is one of these words that have gone around the last years. I'm sure you're familiar with it. And I've always wondered, when I first heard the word, I'm like, well, cloud native, well, that makes sense. It probably means that it was something that was born in the cloud, right? And then later it came to mean something else, Kubernetes, or, then, Cloud Native Computing Foundation gave it a definition. What do you think it means? What does that word cloud native mean to you? How would you define it?
I think it's a matter of thinking. It's a matter of, I'm an immigrant. So take it from another space. I'm an immigrant. I was born in the Soviet Union and moved to Israel when I was a kid. And every immigrant goes through that transformation of changing the language that you think in and the culture that you operate in, what you can do, what you can do, before you assimilate and start to think as a local. Mm-hmm. And some people never go through that. Some people struggle that for a long time, and this kind of transformation. So I'm taking that on a personal level, but cloud is just so different in the way that you have to think about technology stack. You have to think about solutions, and the way that you have to think about, realize that it's about how you use these internet resources, and realize how you talk in that lingo. It's actually like completely changing the language that you speak in, and the culture that you work in. I think that cloud native is about doing that immigration, doing that transformation in the ways of thinking. This is, by the way, one reason why hybrid technology stacks still struggle to find the best practices there, or how to do that, because one is a bit alien to another. So you force one way to work like the other, losing. Doesn't matter which way you do that, forcing, but losing somewhere along the way.
Yeah. I love that answer. I mean, I immigrated, a Mexican American who lives in the Netherlands, so I completely relate to everything you're saying. The moving from one place to another, in a way, you never really become completely local, but you can make an effort and get there, and you can tell immediately the difference with someone who is actually local. So that's a great answer. um, I think obviously, as time goes on, more and more things, I think the term will go away, actually. I think it will just become IT again. So I really appreciate your time. It's a great chat. I really love learning about these new and different technologies. I say a lot of the people I talk to solve problems that we only created a few years ago. So they're like, all this stuff is really new. And I'm glad that we could give a preview a little bit for people who are just getting introduced to this, as I think this sort of solution is going to become more and more important. So looking very much forward to working with you further and speaking with you again soon, hopefully. Thanks very much.
Thank you very much for your time.